I'm going to talk about your work on standard form, the assignment, and across the top it says in my handwriting, equivalent forms and interpret in context, so that's the focus of this assignment. You're going to want to have a piece of lined paper attached. If you don't have one, stop the video so you can get one and label it up. And I probably shouldn't write in green pen, but all I wrote was the title. Get that out of there. Alright. I have my calculator next to me, too, in case I need that. In the first problem, you have to match each equation with the statement about its vertex or y-intercept. And I just want to remind you of a couple things. You can jot these notes for number one. So an assist in number one, your vertex is going to come out of an equation written in standard form as the h and the k. Don't forget, we've talked about this, we've used this, this isn't new. And the y-intercept is going to come out of an equation that's in standard form. It's the c value. So in number one, that will help you make the choices that you need. You can leave some space on your paper so you can go back and write down your answers. Actually, you could do this. 1, 2, 3, 4. Go back in a few minutes. For number two, asked for in each parabola, give the vertex, expand it to put it into standard form and state the y-intercept. So we might have to go at this a couple different ways. Let me first focus on one of the equations for number two that's not in vertex form and work with you to expand that. It's going to be the equation VI, or 6 in these little Roman numerals. Y equals 3 times x minus 0.5 times the quantity x plus 2.5. So what I'm going to do is work to put this into standard form, because once I'm in standard form, I know that I can find the vertex and use the a value to write the equation in vertex form to answer questions. I'm going to write this a little bit larger so you can see. So the first thing I'll do is take and multiply the two binomials that are part of this. I'll wrap some brackets around it to show you what I mean. And then after I do this, I want to bring all the values out of the boxes and distribute that 3. I don't want to forget to go back and distribute the 3. And I think that half of 2.5 is going to be 1 1/4, and it's negative 0.5 times 2.5. Yeah, negative 1 1/4, like I thought. And so when I bring this outside of the box and my 3 that has to be multiplied by everything, I'm going to have x squared. Let's see. Plus 2x. These two together are going to give me 2x minus 1 1/4. So now I'll distribute my 3 and I will be in standard form. Standard form, here we come. 3x squared plus 6x minus, I see my signs out front, what I'm multiplying by, and that's going to be 3.75. Think about it like I have $1.25 3 times. $3.75. Alright, cool. So I'm in standard form, and the reason that that's going to help is for number 2 in standard form, what I need to do, that's actually part B for number 2. This equation's part B. That's done. Part A wants the vertex. Part C wants the y-intercept. I'm going to grab that real quick. The y-intercept is sitting there as my C value. That's equal to negative 3.75, just like we've done before. Don't forget to take the sign. Negative 3.75. And letter A, we need the vertex for this. So the vertex for this is going to be found by, the x value is going to be found by the opposite of our B in standard form. My A is 3. It's going to open upwards. My B is 6. My C is that negative 3.75. Negative B over 2 times A is going to give me the opposite of B over 2A. It's going to give me negative 6 over 6. It's going to give me negative 1. So the vertex is going to have an x value of negative 1. And when I go put negative 1 into my equation, this is getting kind of messy. I write so big. I'm going to put it into my standard form equation. Y equals 3 times negative 1 squared plus 6 times negative 1 minus 3.75. Boy, oh boy. I'm going to go right to my calculator and put all that in parentheses and all. Negative 1 squared plus 6 times your negative 1 minus 3.75. It's going to give me a y value of negative 6.75. There's my vertex. So that's the extent of the work that you'd have to do for number 2. You've got 5 more to do, and I think I picked the most complicated one to show you. In number 3, I think the strategy of using your y equals on your calculator, number 3 wants you to determine whether the two equations are equivalent, which means they'd have the same parabola. So I think we did an activity, an assignment about this. It was called Same Parabola, Different Equation. And we entered both the equations into our y1 and y2. And I'm just doing that with the first pair. I'm using 0.5 instead of the half, x to the second power. I'm using the first pair in number 3. Oh, nuts, messed that all up. X, nope, 0.5x squared. Try it again. Minus 6x plus 30. Just double check that I entered these two equations in right. Plus 12. I'm going to hit graph. If you don't have a nice pretty graphing window like I do, don't forget we can use the function, the zoom function. I don't see anything, darn it. I can always use zoom 6 to give us a standard window, but in this case I think I'm going to have to expand my window. Let's see. Ooh, this isn't hitting the y-axis. One of these isn't hitting the y-axis until it gets to 30. So I know I need to have... Oh, these guys are going to open upwards as well. They both have a positive a. I'm going to throw that y maximum up to 100 and see what happens. There we go. Got a picture of it. So I used the y-intercept to give myself an idea of where this was going to hit the y-axis to expand my window. And it stopped working, and I'm not seeing two different parabolas. So these must be equivalent parabolas. So your justification would be explaining that you looked at it using your calculator and you didn't see two different parabolas. They were the same. When you go on to 4, 5, and 6, I suggest you draw a picture of what you know as you read. In number 6, the first thing I would do in order to figure out your maximum would be to expand that function h of t into standard form. And you can use that to find your maximum and your vertex. And be persistent in solving your problems. If you need to, go back to some of the work that you've seen on other videos where you can pause it and look at it by yourself. Good luck.